Hey GameMakers, I just wanted to do a quick show and tell about a feature that a lot of people don't know about and don't realize they can take advantage of, and that is using direct 3D transform functions when building a 2D game. Uh, Let me show you what that looks like real fast so you know what I'm talking about. So notice how the card is spinning and the edges of the part of the card that's in front of the other edge of the card is actually getting wider with a perspective drawn on it. Uh, Really cool effect. You know, usually if you're flipping a card in your 2D game, you're just using image Y scale or X scale to have it rotate or appear to be rotating. And it's not a terribly convincing effect. But doing this is actually really simple in any 2D game. So there's a few little tricks, but let me show you how it works. So um, most of the heavy lifting is done in the draw event here, but and as you can see, I've commented this code really well, and I'm not going to go through all of this code because I think you should read through the code and experiment it with your by yourself to kind of figure out how it all works. But I'm going to make some key points. So d3d set projection perspective is what gives it that 3D look. There's some really weird caveats with using this. Essentially, if you were to, this asks for an X and a Y position and a width and a height as its arguments, and then an angle. Uh, if you do 0, 0, room width, room height, or view width, view height, or view X, view Y, you know, view width, view height, uh, it flips the Y coordinate system. So anything below the center of the screen will appear above the center of the screen and vice versa. Don't know why, it's a little weird. So instead we give the Y value as the room height and then the height as a negative height. I honestly can't explain that. It's just a weird caveat to using this effect. Uh, so keep that in mind when you use this. Uh, Next, and this is really the key thing, you can set your rotations, all of these different d3d transform functions. So right now I'm doing a rotation over the y, but if I were to comment this out, uncomment my x, and then I got to change this to set. Whenever you have a group of d3d transforms, you always want your first one to be set and your last, all the other ones to be add. If you use set down here, it'll ignore this one completely and only use this one. So you always got to make sure that your first one is set and then all the rest of them are add. So let's see what it looks like when I have an X flip. Now it's flipping around along the X axis. So that's pretty cool. So if I do both of them, do a set and an add, now it's rotating along both axes. Kind of a funky looking animation, but usually you'd want one to uh, uh, rotate slower than the other, but they're both rotating at the same rate, so you get kind of this funky back and forth looking animation, but the principle is the same. Uh, so this next part that's really important for how this works, and you can see I've put a huge block here, but I'll explain it quickly as well. I'm going to explain this in kind of reverse order. So when you draw using these transform functions and these, projection settings, you need to draw as if you were drawing around the origin of a surface, basically. So you'll notice I don't draw my vertices here to, you know, room width times 0.5 minus width, room width time, room height times 0.5 minus height. I just do negative width and negative height. So it's like my height is uh, card width times 0.5 and card height times 0.5, which is just the width and height of the sprite. Uh, so that's like negative 20, negative 100, positive 20, negative 100, positive 20, positive 100, negative, whatever. So I'm using some negative values, and this means that my origin is essentially around is 0, 0, and I'm drawing the primitive points around that origin. Then, and it's kind of weird, I know, but the D3 transform is going to move that origin before we draw it to wherever I want. So right now it's X and Y, which is room width times 0.5 and room height times 0.5, but it's really easy to change that to whatever you want. So I can have it follow my mouse. Uh, so let me show you what that looks like. So now it's following my mouse wherever I go. And you'll notice that the center of the screen is your focal point, your vanishing point for this perspective. It's like a 1-point perspective. So if I put it in the top right, you'll notice it looks like we're underneath the card. And if I put it down in the bottom right, we're above the card looking down at it a little bit. It's a really cool effect, and obviously not terribly difficult to achieve. And it works with anything. So right now I'm drawing a textured primitive, and I'm like swapping out the texture based on the angle of my rotation. So it's either the front texture or the back texture, and it's just the same polygon that I'm drawing. No big deal. But you don't have to be limited to primitives. So if I comment that out, and I comment in this, so I'm drawing a rectangle, a circle, and a line. So let's see what that looks like. And you'll notice I'm getting all the same perspective and rotational cool stuff automatically. And I don't, if you've never tried to rotate some of these elements programmatically, like drawing a rectangle, rotated, is usually just a total pain, especially if you're trying to do something like just a rotate, right? Like a 2D regular rotate, a spin, if you will. It can be a total pain. But there it is. And the code almost couldn't be simpler. So it's really cool. And it also works for sprites, obviously. So I'm just going to draw let me go back to a Y rotation. And there you go, same thing. Now obviously the texture is not changing because I didn't bother doing that, but you can do this with any sprite. So it's really powerful, and it saves you, especially when drawing rectangles and lines and circles and stuff like that. It saves you from having to do complicated math to draw primitives at an angle using trigonometry and length direction x and length direction y and all that jazz. And this is just so much faster because you don't have to do any of those computations, and you just let the d3d stuff handle it. Finally, when you're done using your projections, you need to do a couple of things. You need to use d3d transform set identity. This is just kind of ends your drawing. You're done using these d3d functions, and you just want to go back to your normal functions and make sure everything draws just like the rest of your app does. So you need to do that to sort of end everything. And finally, you need to set your projection back to ortho. Again, 0, 0, room width, room height. And this will just turn everything back into standard 2D projection that you expect from GameMaker, the default behavior, basically. And that's pretty much it. You can mess with all of this stuff. I create the card surfaces for that first example here. So if you wanted to layer multiple sprites on top of each other in a single surface, create a texture from that, and then paste it onto a primitive, you could. You could do much more complicated primitives, such as octagons or any shape you want, really. And so play with it and give it a shot. try implementing it uh, into your game if you've got somewhere you could use this. And let me know what you think or if you have any questions. Cool. Have fun.